All right, strap in, everyone. We're going deep, really deep this time.
Diving into the biggest question out there,
Hmm.
maybe?
Yeah, are we alone? I mean, come on, who hasn't thought about that,
Yeah,
right?
you've given me like a whole astrobiology course worth of stuff to dig through.
Well, we're going to unearth some seriously fascinating insights, especially, I think, for those of you, you've been around the block on this topic.
Yeah, and the cool thing is we're like living it right now. Technology, research, it's all exploding.
Totally, like science fiction is becoming reality.
No kidding. So this course, it like starts us off at the Big Bang and then boom, all the way to alien hunting.
But let's be real, our listeners aren't starting from scratch.
Oh, for sure. Everyone here already knows their stuff. Like, we all know the Big Bang made a universe full of hydrogen and helium. Basic stuff.
But then how do we get from that to, like, us, to life?
Ah, that's where the big guns come in, literally.
You mean those huge early stars?
Exactly. Those were like cosmic furnaces, right? Infusing those simple elements into the heavier ones.
Carbon, oxygen, nitrogen, the building blocks.
Right. It's kind of wild to think we are literally stardust.
Whoa. Okay, that is poetic. But so then fast forward a few billion years, solar system time.
Our solar system, yeah. Swirling gas and dust, sun ignites, boom. Leftovers start clumping together. Planets.
But why Earth? What made our little blue marble so special for life to, like, get going?
It's this crazy mix of chance and, like, things had to be that way. Earth formed in the sweet spot, not too close, not too far from the sun.
Goldilocks zone, right?
Bingo.
Yeah.
Temperature's just right for liquid water.
Not too hot, not too cold, perfect for life.
Oh, and didn't we also have some intense moments early on?
Oh, yeah, giant impacts, massive collisions.
Those weren't all bad, though, right?
Nope. Shaped Earth in some ways that were actually, like, crucial for life.
Our moon, for example. Pretty sure that came from a giant impact.
Huge impact, early Earth.
Yeah.
Totally changed the game. Moon stabilizes our tilt, gives us seasons.
And it's gravity, that's what gives us tides. Didn't those help life evolve? Big time. But early Earth, even with the moon, wasn't exactly a walk in the park.
Oh, yeah, definitely not paradise. I mean, toxic atmosphere, no oxygen.
Right, a far cry from what we know today. But even then, life found a way.
Those extremophiles, man. Talk about hardcore survivors.
Driving in places that would kill most things, like scorching hot ocean vents.
Or microbes buried deep in the Antarctic ice.
It's mind-blowing. Makes you realize life might be out there in places we never even considered.
Like, if it can survive that here, who knows what's possible on other planets, right?
Totally. So we're going beyond Earth now. But where do we even start in our own solar system?
Mars seems like the obvious first stop.
Mars, yeah, our neighbor. There's some pretty convincing evidence it might have been way warmer and wetter once.
Like, maybe even had life.
Could be. Think about those potential Martian fossils found in Antarctica.
Wait, really?
Yeah. Still debated, of course, but some scientists think those could be proof of ancient Martian life carried here by meteorites.
That's wild. But if Mars was so nice, what happened? Why is it a desert now?
It lost its magnetic field. That's what shields a planet's atmosphere from the solar wind, you know?
So no protection, atmosphere gets stripped away.
Exactly. Leads to those harsh conditions we see today. Sad, really.
A reminder that habitable doesn't always last. To see how bad it can get, let's compare Mars with Venus.
Venus, oh boy, that's like Earth's evil twin.
Because it's so similar in size and stuff.
Yeah, but scorching hot wasteland, runaway greenhouse effect, trapped all the heat.
I've heard it's like over 800 degrees Fahrenheit on the surface.
No thanks. So yeah, Mars might have clues about past life, but Venus is a warning sign.
Okay, so if we're looking for life that's around right now, not just fossils, where do we look?
Things get super interesting here. We gotta shift gears from rocky planets to, get this, icy moons.
Icy moons.
Yeah.
Really? Those don't exactly scream life at first glance.
It's what's under the ice that matters. Huge oceans, liquid water, the whole deal.
Wait, oceans under the ice? How is that even possible so far from the sun?
Tides, man. The pull from those giant planets they orbit creates friction, heats things up.
So enough heat to keep the water liquid under all that ice.
You got it. We're talking serious potential for life here.
So which moons are we talking about specifically?
Europa is a big one. One of Jupiter's moons. Smaller than our moon, but scientists think its ocean could hold more water than all of Earth's oceans combined.
Wow, that's a lot of water.
Mm-hmm.
And where there's water, there could be.
Life, potentially, yeah.
Yeah.
And Europa's not alone. Ganymede, another of Jupiter's moons, it's massive, also has signs of a hidden ocean.
These icy moons are blowing my mind. So what's next? Any missions planned?
Oh yeah, exciting stuff coming up. NASA's Europa Clipper mission is set to launch soon. It'll orbit Jupiter, make close passes by Europa, study the ice, and search for plumes.
Plumes, like geysers shooting out from the ocean.
Exactly. We might actually get a glimpse of that hidden water.
That's incredible. What about Ganymede? Any missions headed there?
The European Space Agency is sending Jupiter Icy Moons Explorer soon.
Catchy name?
It'll visit Europa, Ganymede, and Callisto. Lots of data coming our way. Should be amazing.
Jupiter's got some cool moons for sure. But what about Saturn? Anything interesting there?
Saturn's got a moon called Titan, and it's like nothing else.
Titan. Isn't that one super cold?
It is, but it's got a thick atmosphere. And get this. Lakes and rivers, but not water.
Wait, what? What are they then?
Liquid methane. Imagine that landscape. Methane rain, methane lakes, icy beaches.
Like totally alien. Could life even exist in a place like that?
That's the question, isn't it? It totally challenges how we think about life.
Okay, we got to talk about Enceladus too, right? Another of Saturn's moons.
And Enceladus, picture this. Massive plumes of water vapor shooting hundreds of miles into space.
Seriously, where's all that water coming from?
A hidden ocean, what else?
Wow.
And those plumes, they've got organic molecules, the building blocks of life.
So Enceladus, like Europa and Titan, could have life too.
It's definitely a possibility. And those plumes make them easier to study. We get samples without even landing.
So valuable for research. It's amazing how many hidden, potentially habitable places there are in our solar system alone.
It is, right? Just our little corner of the galaxy. Now imagine looking beyond our solar system to all those stars.
Okay, now we're getting into some seriously uncharted territory.
That's where it gets really exciting.
The search for life beyond our solar system. But before we go there, let's take a quick break. We'll be right back to continue our deep dive.
I mean, it really makes you think, right? All those stars, all those planets.
It's crazy. And for so long, we could only, guess about planets around other stars.
Right, but now we've got these super powerful telescopes, new ways to find them.
Yeah. The Kepler Space Telescope, that was a game changer, right?
Oh, absolutely. Kepler just stared at this one patch of sky for years, watching over 150,000 stars. Can you believe it?
Looking for those tiny dips in brightness when a planet passes in front.
Like a mini eclipse. And from that, Kepler could tell us there's a planet there, how big it is, all kinds of stuff.
And what did Kepler find?
Planets everywhere, thousands of them. Turns out planets are way more common than we ever thought.
So, more planets than stars in our galaxy.
That's the current thinking, yeah.
Whoa, okay, that's a lot to process.
Huh.
But of all those planets, any of them, livable?
Ah, the million-dollar question. And the answer is, drumroll, please. Yes.
There are, for real.
Kepler found a bunch that are Earth-sized, and in that sweet spot, the habitable zone, around their stars.
We're talking exoplanets, right?
Exoplanets, exactly. Planets outside our solar system. Still kind of futuristic to say it, isn't it?
It really is. But wait, there's more, right? Kepler found something else too.
It did. A whole new type of planet. Super-Earths.
Super-Earths. What are those? Like Superman's home planet or something?
Not quite. They're bigger than Earth, but smaller than Neptune. And their size, that brings up all sorts of new questions about life.
Like what? Give me an example.
Well, think about gravity. A super-Earth, stronger gravity, right? How would that affect life evolving? Could it hold on to a thicker atmosphere?
Making it more livable?
Maybe. Or maybe it traps too much heat and makes it too hot. We're just scratching the surface here.
Man, it's like every discovery leads to 10 more questions.
That's science for you. It's a journey, constantly pushing the limits of what we know.
Okay, so habitable planets, check. But the big question, is there anyone out there? Like intelligent life? How do we even begin to answer that?
It's the question, right?
Mm-hmm.
And now, finally, we have the tools to start looking scientifically. One way is to search for technosignatures.
Technosignatures. What are those, like alien Instagram posts?
Not quite. It's evidence of tech built by a civilization. We might pick up weird radio signals, something that doesn't look natural,
Like deliberate communication from another world.
Exactly. Or we might see megastructures.
Megastructures.
Yeah, like massive structures built by an advanced civilization.
Like giant space stations.
Think bigger, like a Dyson sphere.
A what sphere?
A Dyson sphere. It's this hypothetical thing, a structure that surrounds a whole star to capture its energy.
Whoa, okay, that's next level. Have we seen anything like that? Any megastructures or signals?
Not for sure, no. But the search goes on, and with every new telescope, new technology, we get better at finding stuff.
I hope we find something soon. But it makes you wonder, right? If there is intelligent life out there, and the universe is so old and huge,
Yeah.
why haven't we met them yet?
You've just stumbled upon the Fermi paradox, my friend.
The what now?
the Fermi paradox. It's this question that's been bugging scientists forever.
Hmm.
If they're out there, where are they?
Okay, yeah, that is a bit of a head scratcher. Any theories about why we haven't bumped into any aliens yet?
Tons of them. Maybe intelligent life is super rare, and we're like the only ones who made it this far.
Or maybe civilizations, they just wipe themselves out before they can get to the space travel stage.
Could be. Or maybe they're out there watching us, just waiting for the right moment.
Okay, now you're just messing with me.
Mhm.
But speaking of space travel, what about us? Think we'll ever get beyond our solar system?
Interstellar travel. That's the dream, right? But the distances, man, they're just too huge with what we've got right now.
So no hopping over to Proxima Centauri for lunch anytime soon.
Not unless we figure out warp drives or wormholes.
And warp drives, wormholes. Is this Star Trek now?
It sounds like it, but scientists are actually working on the math, the physics of it all, you know?
To see if it's even possible.
Yeah. Never underestimate human ingenuity, right?
It's cool how sci-fi inspires real science. But realistically, maybe we should focus on, taking care of our own planet first.
Oh, absolutely. Earth is home, at least for now. Gotta protect it. But thinking ahead, what if we need to find a new home someday?
Because Earth isn't livable anymore.
Yeah, or maybe just to ensure humanity survives, spread out a bit. And when we think about that, Mars is the obvious first choice.
Close. Some resources we could use. But terraforming, making Mars livable, that's a huge job.
It would be epic. Thicken the atmosphere, warm it up, get some water flowing. We're talking tech we haven't even invented yet.
And there's the whole ethics thing too, right? Like, do we have the right to change a whole planet?
Yeah, big questions to think about. Gotta be responsible about it all.
What about other options? The moon, maybe?
Some people have suggested that, or even those big asteroids.
Asteroids.
Yeah. They have resources, but they're small, weird shapes, tough to build on. The moon, no atmosphere, low gravity, not ideal.
Sounds like interstellar travel, going to other star systems. That's still a ways off, huh?
For now, yeah. Too far, too much energy needed. But who knows what the future holds? Maybe we'll crack the code someday.
Changes crossed.
Yeah.
But in the meantime, Earth is what we've got. We better take good care of it.
Couldn't agree more. Yeah, it really does put things in perspective, doesn't it?
It makes you feel kind of small,
In a good way, though, right?
Yeah, like, wow, we're just this tiny part of something so much bigger.
And we're just starting to understand it all.
And the crazy thing is, it feels like every day there's some new discovery, some new breakthrough.
It's true. Like, the pace of science right now, it's mind-blowing.
Okay, so we got to talk about the James Webb Space Telescope.
Oh, yeah, the JWST, that's a game changer.
I mean, those pictures of those galaxies billions of light years away,
It's incredible, right?
just incredible. It's hard to wrap your head around it.
Totally. But it's not just about pretty pictures. The JWST is also a powerful tool for, the search for life.
Really? How so?
Well, it can actually analyze the atmospheres of exoplanets.
Wait, seriously?
Yeah, by studying the light that passes through a planet's atmosphere, we can figure out what gases are there.
So we could, detect signs of life on a planet light years away just by looking at its air.
Exactly. We're looking for what we call biosignatures.
Biosignatures.
Yeah, specific combinations of gases that are strong indicators of, life.
Like what?
For example, if we see oxygen and methane together in an exoplanet's atmosphere,
That's a good sign.
it's a very good sign that something biological might be happening there.
It's like we're living in a sci-fi movie.
I know, right? Science fiction is becoming science fact.
Okay, let's play pretend for a minute. Imagine we do find proof of life on another planet. Like, real proof. What would that mean for us?
Wow, that's a big question.
I know, but just think about it for a second. How would it change things?
Everything, probably. I mean, our whole understanding of our place in the universe, our philosophies, our religions, everything would be up for grabs.
It'd be a whole new world.
Literally and figuratively.
Okay, but what about actually talking to them, these aliens, if we find them? I mean,
That's a whole other challenge.
yeah, how do you even start a conversation with something that evolved on a totally different planet?
Right. It's not like we can just, ask them what's up.
Plus, there's the distance, right?
Huge distances, messages could take centuries to travel back and forth.
No quick chats then.
Not unless we figure out how to break the speed of light.
Okay, that's probably not happening anytime soon. But let's say we do find a way to talk to them. How do you even find a common language?
That's the million-dollar question, isn't it?
It's like, how do you talk to an ant,
It might be impossible, but I have faith in human ingenuity. We're good at figuring things out.
Especially when we have to.
Exactly. Necessity is the mother of invention, right?
Absolutely. Okay, bringing it back down to Earth for a minute. You mentioned humans becoming a spacefaring civilization. What do you think the next steps are to actually make that happen?
I think it comes down to, keep pushing the boundaries
Of what?
of space exploration, of technology, of our own understanding.
Yeah, like we need to invest in research, in new ideas,
And we need to work together as a planet.
global collaboration. That's key, right?
Absolutely. This isn't a one-country mission, it's a human mission.
And we need to inspire the next generation.
The kids who are going to solve these problems figure out how to live on other planets.
So we're still at the beginning of this journey.
Oh, yeah, for sure. We're just taking the first steps, but the potential, the possibilities, they're limitless.
Well, this has been an amazing deep dive.
Really has.
I mean, we've gone from the Big Bang to aliens to the future of humanity all in a few hours.
It's a lot to process, I know, but I hope it's been, inspiring.
Inspiring and thought-provoking for sure.
And maybe a little bit scary, but mostly exciting.
Mostly exciting. Yeah, I agree. It makes you want to go out and learn more, do more,
That's the goal, right?
to spark that curiosity, that sense of wonder about the universe.
Exactly, to get people thinking about the big questions, the really big ones.
So on that note, I think it's time to wrap things up.
Time to come back down to Earth for now.
But keep looking up, everyone. You never know what you might discover.
Thanks for joining us on this deep dive.
And until next time, keep exploring.